In this video, we are going to see how we can convert a PDF to a podcast in fully automatic manner. To demonstrate this particular project, I take example of the attention is all you need paper, and I converted that to this particular podcast. So let's hear a podcast a little bit.
Welcome to our podcast where we explore the latest advancements in AI and technology. Today, we're joined by Ashish Vaswani, a renowned expert in the field of AI, to discuss a groundbreaking new approach to machine translation. This innovative architecture, called the transformer, eliminates the need for recurrent or convolutional neural networks and instead relies solely on attention mechanisms. Let's dive right in. Ashish, can you explain the problem with current sequence transduction models and why the transformer was developed?
I was reading this paper, and it's so cool, but I was like, what's the problem with the current models? Isn't it that they're just too slow?
So you see, we can also have different accents for each speaker, and we are going to do this fully automatic manner using the Meta's Llama large language model. So whatever I'm going to show in this particular video is taken from here. A little bit modification I did on my part. You can go to Llama Cookbook end-to-end use cases and notebook Llama. Here they show that how you convert a PDF file to a podcast, but they also use bigger models like let's say 70 billion parameter model, but I did not. And in the end part, I instead of using this Parler TTS or Bach Suno, I used another text to speech converter. But yeah, more or less it's pretty much same. You can directly come here and follow this repository as well. With that out of the way, let's dive straight to the video. First of all, we'll import the Llama model that we're going to use for this. For this one, I'm using 3 billion parameter model and the instruct fine-tuned version of it. So after that, I initialize my model. I also initialized my tokenizer, and I specify my pad token to be the end of sentence token. This is not also necessary. It can do it automatically as well. In the following step, we're going to extract text from the PDF file. So in this case, I'm using the attention all you need research paper. I downloaded it from the archive. So here I'm using the PyPDF 2, and from there I'm using the PDF reader. I'm passing my file, this particular file path, and I'm in this PDF reader. I can have multiple attributes. For example, if I write PDF reader.pages, I can get how many number of pages I have, and then I go through page by page. I extract the text, and I set a limit that I am going to have maximum 100,000 character, but I think that's more than sufficient for us because we were managed to go through all the pages and we have total character of 39,000 all. Now if I do print final text, I can see what the text has been extracted from this PDF file. But this is extracted from a PDF, there can be a lot of disturbances such as characters, formatting, latex tables. So what we are going to use, we are going to use a Llama model that we just imported to clean this text. So for that, we'll provide a prompt to the model, and here is the prompt. You can pause the video to read it thoroughly. We are asking it to clean the text. Instead of giving our Llama model this all the text at once, all of this extracted text at once, we are dividing this into smaller chunks so that it is easier for the model to get a better understanding and do a better job. And for that, we created this function. So what it does, it creates a word bounded chunks. That means if you do a character bounded chunk, then there might be chances where a word is splitted. So here we do word bounded chunks, so it's more semantic. No word is splitted in the middle. Here I specify my chunk size to be 1000. And next, what we are going to use, we are going to take each of this chunk and pass through our Llama model. And the Llama model takes a system prompt which says that, okay, clean this text, and the text chunk, which is the text to be cleaned. And after that, we get the output here, and then we decode that output using tokenizer. That's it. So for example, for the I think the 22nd chunk, here is the input text. Doesn't make much sense, of course. And here is the processed text. Here is the processed text. You see all this gibberish like 7.0 the numbers, which usually doesn't make much sense in this context, they're all removed, and they are put in a much understandable manner. This is just for one chunk, but we are going to do it for each of the chunks. Here is the function. What it will do is it will take a chunk of text and pass it through our model, and here is our cleaned text from the extracted text from the PDF, and this is the processed text. So now we just have to do a for loop. So here is our for loop. It goes through each and element of the chunk, pass it to the process chunk function which we created before. It basically passes through the llama model, the language model, and get the process chunk. Now this process has started. It takes a few time. It takes, here it says, around 3 minutes. So yeah, our pre-processing of the text has been finished, and we saved that in a txt file. Let me open the txt file. So here is the extracted text. You see, it's not very big, but I think everything we need to know is here according to the language model, because in the end our goal is to make it more conversational so that two people can generate conversation out of it. And now let's move on to the second part, where we will use this processed text to generate conversation between two people. For this model as well, I'm going to use the same llama model. Don't worry, all this Jupyter notebook files you can find in the GitHub, which is linked below. And now I create a new system prompt. And yeah, this system prompt is to create a script for a podcast. For example, here I specify that your job is to write word by word, even right, which makes it more human-like, the conversation. Also, I say that the speaker one leads the conversation and teaches the speaker two. And I also mention something like always start your response directly with speaker one. Do not give response title separately. Let speaker one. Some guidelines. Now I'm reading from the cleaned extracted text that I just showed you. Yeah, and now I'm converting them to in the message format which the llama model takes in. So right now I'm using all the processed text that I created before from the raw extracted PDF files, and I'm making it more conversational friendly. Yes, our pre-processing is done. It takes a while because we are asking it to generate 8,000 tokens. And let's see the results. Most of the starting part are what we ask it to do, the system prompt. Then it starts the actual text of the paper, and from I think here it starts the actual thing from here. The transformer model, a game changer in the field of natural language processing. You know, the key to its success lies. And the speaker 2 says, that's really interesting. So it's like the model is trying to understand the context of entire conversation, not luck. So it basically summarized the whole attention all you need paper as a two speaker are talking to each other. It also adds something like laughs and everything to make it, but I don't think it's gonna work. Now I'm dumping all this text into a pickle file. I'm rewriting it in a dramatic manner as I wrote here, and I want the model to give me in such a manner. They're all a list of tuples where the first element of tuple is the speaker and then the what the speaker is saying. So this is to guide the model and say that okay, generate me something in this format so that I can pass it directly to my text to speech model, which will convert this text to speech, in fact. Exactly, as simple as that. Now I again initialize my transformer model, the pipeline in fact, and I put my max token output equal to 10,000. So yes, our output has been generated. Let's check it out. So yeah, here you see that it gives multiple things, but we are just interested in the generated text. So what we get is something like this, which is amazing that we got in a list format, and inside everything is in tuples, which we easily just run a for loop and we can extract each speaker and what they are saying, and we can pass it to a text to speech model to generate the podcast that we want. And I finally put all this generated text in a pickle file. Now coming to the final part of the project, I'm going to use this Kokoro TTS. This is very popular recently because it's a very small model and with better accuracy than I think 10 times bigger model. It has only 82 million parameters, so you can easily run it on a CPU as well. For that, you just have to run this command first. You don't need to use Hugging Face for this part. You need to run this. I already run this command, so I don't need to do it again. And from the Kokoro, import K pipeline. So here is the Hugging Face homepage of the Kokoro. And if you go to the voices, here you see that there are different voices present. For the American voice, there are a lot of options which you can choose from. There is other accent as well. You can have British English, there is Japanese, Mandarin, Spanish, French, Hindi, in case it's an Indian accent to be precise, Brazilian Portuguese, and whatnot. So what we have to do is we just have to know this code. This is the, here A stands for American, F stands for male or female. So here it's female, and then AM stands for American male. And then there are like different names given to each character. And here you see hours. When you see hours, that means it has been trained on hours of data of this particular person. Minutes represents minutes of data. So I would recommend you to stick to HH hours and the highest target quality, so you get a better like inference for that matter. So coming back here, I I initiated my pipeline with the language code A, which is American in this case. I'll use all this processed text that I just generated. What I did is, there are methods where you can, because right now this is just a string, and I want to use it as let's say a list of tuples. You can use, there are some methods present, but what I did, I just copied this and pasted right away here. Now what I did is I created two different speaker, because one, I would like that speaker 1 and speaker 2 sounds different. So here I did like American female Nova as my speaker 1, and my speaker 2 is an Indian accent, Indian male accent Omega, Hindi male Omega. So it's pretty simple. So what you do in the pipeline, you have to pass the text. This pipeline is what we just created right now, this particular one. And in that pipeline, what you have to do, you just have to pass the text and the voice that you want it to convert your text to, and then the generator. And in the generator there are multiple things, but we are just interested in the audio. There are like phonemes, and I'm not sure what is let me check. Yeah, graphemes and phonemes. I'm not much aware of what they are, but we are just concerned about the audio for now. This is we put it in now empty list of audio, and we can concatenate that. What I did is, right now I loop through my podcast text. So this is my podcast text, this particular one, and in, let's say, the first element, first element is a tuple, where the inside the tuple the first one is speaker 1, and then what the speaker is saying. So what I do is I check if the speaker is 1, then pass it to my text to audio speaker 1 function that I created here, otherwise to the other one, and then just append that to the audio. It's pretty fast. Okay, I have to run this. You see, this is pretty fast. And now we get our podcast. So now let's play the podcast and listen.
Welcome to our podcast where we explore the latest advancements in AI and technology. Today, we're joined by Ashish Vaswani, a renowned expert in the field of AI, to discuss a groundbreaking new approach to machine translation. This innovative architecture, called the transformer, eliminates the need for recurrent or convolutional neural networks and instead relies solely on attention mechanisms. Let's dive right in. Ashish, can you explain the problem with current sequence transduction models and why the transformer was developed?
I was reading this paper, and it's so cool, but I was like, what's the problem with the current models? isn't it that they're just too slow? Haha, I mean, like, they need a lot of training time and resources.
So yeah, it's a little funny because the haha part I put myself, and it uh, did not convert it to a very natural sounding speech. But yeah, it's very good to test with. Maybe you can tweak with a lot of things. And if you enjoy this, then don't forget to subscribe to the channel. I'll be bringing in more content related to Llama model and fine tuning of it. So stay tuned and stay curious.